Bonjour à tous les amis, j'espère que vous allez bien. Aujourd'hui on parle de Rust, on parle de game dev et on lit le chapitre Context Objects aren't flexible enough. C'est parti.
Context objects aren't flexible enough. Since Rust has a relatively unique set of constraints on programmers, it ends up creating a lot of self-inflicted issues that end up having solutions that don't necessarily come up in other languages as often. An example of this is a context object that gets passed around. In almost every other language, it's not a big problem to introduce global state, be it in the form of global variables or singletons. Rust does unfortunately make that quite a bit more difficult for all sorts of reasons mentioned above. First solution that one would come up with is, just store the references to whatever you need for later. But anyone who has used Rust for more than a few days will recognize that this is just not going to be possible. The borrow checker will require every reference field to have its lifetime tracked, and because lifetimes become generics that poison every single usage point of the type, it's not even something that can be easily experimented with. There's more than one problem here, but I feel the need to point this out a bit more explicitly, as it may not be obvious to those who haven't tried. On a surface level, it may seem that, what if I just use the lifetimes, e.g. struct thing, a greater than x, and AI32. The problem is, what if we now want to fn foo, t, and thing? Well, of course we can't. Thing is generic over a lifetime, so this has to become fn foo, a, t, and thing, a, or worse. Same thing if we try to store thing in another struct, now we end up with struct potato, a, size, f32, thing, a.
Moi je trouve à chaque fois les lifetime, le fait que c'est pas le compilateur qui décide de la lifetime et qui est capable de le savoir, c'est à toi le programmeur d'expliquer et d'exprimer la lifetime. Je trouve que c'est un truc hyper moche dans Rust, et le fait que le lifetime il soit associé au type, enfin que voilà il se propage partout comme vous pouvez le voir là, je trouve que c'est d'une laideur sans nom effectivement, et franchement je sais pas s'il proposera une solution, mais je trouve que c'est quelque chose qui est vraiment moche dans le langage Rust. Il faut le reconnaître que moi je m'attendais à ce que ce soit le compilateur qui fasse ce genre de travail et pas au programmeur de dire c'est quoi la lifetime d'une variable.
And even though potato might not really care about thing, being in Rust lifetimes are to be taken with utmost seriousness, and we can't just ignore them. Things are actually much worse than they seem, because let's say you do end up going down this road, and try to figure out things with lifetimes. Rust also does not allow unused lifetimes, so say that you have struct foo, a, x, and AI32. But as you're refactoring your code base, you end up wanting to change this to struct foo, a, x, I32. Now that is of course completely prohibited, because you'd have an unused lifetime, and we can't have that. This may seem very minor, and in some languages this is somehow desired even in simpler cases, but the problem is lifetimes often require a decent amount of problem solving and debugging, where one tries a few different things, and trying things with lifetimes often means adding or removing lifetimes, and removing lifetimes very often means, oh, this is now unused, you have to remove it everywhere, leading to gigantic cascading refactorings. I have tried going down this road a few times over the years, and honestly, one of the most infuriating things is trying to iterate on a very simple change with lifetimes, only to be forced to change 10 different places on every single change.
C'est ignoble.
But even if the above wasn't the case, in many cases we can't just store a reference to something anyway, because the lifetimes wouldn't work out. One alternative that Rust provides here is shared ownership, in the way of argc or arc-t. This of course works, but is heavily frowned upon. One of the things I've realized, after using Rust for a while, is that using these can actually save one quite a bit of sanity, although it does require not telling your Rust friends about the code you write anymore, or at least hiding it and pretending it doesn't exist. Unfortunately, there are still many cases where shared ownership is just the bad solution, possibly for performance reasons, but sometimes you just don't have control over the ownership and can only get a reference. The number one trick in Rust game dev is, if you pass in references top-down every frame, all your lifetime reference problems disappear. This actually works very well, and is similar to React's props being passed top-down. There's only one issue, and that is that now you need to pass everything into every function that needs it.
Absolument.
At first it seems obvious and easy. Just design your code correctly and you won't have any issues, lol. Or at least that's what many would say, and specifically, if you're having issues with this, your code is ugly or wrong, bad, spaghetti. Or you shouldn't be doing it that way, and you know, the usual. Lucky for us, there is an actual solution, which is to create a context struct that is passed around and that contains all those references. This ends up having a lifetime, but only one, and ends up looking something like this. Struct context a player, and a mut player, camera, and a mut camera, // Every function in your game can then just accept a simple C, and mut context, and get what it needs. Great, right? Well, only as long as you don't end up borrowing anything. Imagine you want to run a player system, but also hold on to the camera. The player_system, just like everything in the game, wants C, and mut context, because you want to be consistent and avoid having to pass 10 different parameters into things. But when you try doing this, let cam equals c.camera, player_system, c, cam.update. You'll just be met with the usual, can't borrow C, because it's already borrowed, as we touched a field, and the rules of partial borrows say that if you touch a thing the whole thing is borrowed. It doesn't matter if player_system only touches c.player, Rust doesn't care what's on the inside, it only cares about the type, and the type says it wants C, so it must get C. This may seem like a dumb example, but in larger projects, with larger context objects, it becomes unfortunately quite common to want some subset of the fields somewhere, while also conveniently wanting to pass the rest of the fields elsewhere. Now lucky for us, Rust isn't completely dumb, and it would allow us to do player_system, c.player, because partial borrows allow us to borrow disjoint fields. This is where defenders of the borrow checker will say that you simply designed your context object wrong, and that you should be splitting it up either into multiple context objects, or group your fields based on their usage so that partial borrows can be utilized. Maybe all the camera stuff is in one field, all the player stuff is in another field, and then we can just pass that field into player_system and not the whole C and everyone is happy, right?
Yeah, je dirais ça.
Unfortunately, this falls under the number one problem this article tries to address, and that is that what I want to be doing is working on my game. I'm not making games to have fun with the type system and figure out the best way to organize my struct to make the compiler happy. There is absolutely nothing I'm gaining in terms of maintainability of my single-threaded code when I reorganize my context object.
Absolument.
Having done this exact thing quite a few times, I'm very much certain that the next time I have a playtest and get new suggestions for my game, I'll probably have to change the design again. The problem here is, the code is not being changed because the business logic is changing. It's being changed because the compiler isn't happy with something that is fundamentally correct. It may not follow the way the borrow checker works, because it only looks at types, but it is correct in the sense that if we instead passed all the fields we're using, it would compile just fine. Rust is making us make a choice between passing 7 different parameters, or refactoring our struct anytime something is moved around, where both of those options are annoying and wasting time. Rust doesn't have a structural type system where we could say a type that has these fields, or any other solution to this problem that would work without having to redefine the struct and everything that uses it. It simply forces the programmer to do the correct thing.
Tout à fait. Le problème c'est quoi? C'est que globalement, il doit écrire un programme comme si son programme single threaded, comme si il était exécuté en parallèle, il doit refactorer son code alors que normalement son code là il n'est pas exécuté en parallèle, donc il n'y a aucune raison pour laquelle le double borrow c'est un problème. Le double borrow il est interdit pour le thread, pour l'exécution parallèle. Or quand on a du code qui est pas qui est linéaire, on ne devrait pas avoir à le rendre thread safe. Donc il y a cette problématique dans Rust d'écrire son programme de manière safe et parfaite, alors que ça n'apporte rien. Et effectivement du coup tu te retrouves à refactorer ton code alors que t'as pas besoin t'avais pas besoin. Enfin, en gros, il faut que Rust t'apporte de la safety, mais de la safety utile et pas du refactor pour le fait d'avoir du code pur et beau, parce que sa priorité c'est de faire pas du code beau. Moi franchement, j'ai des logiciels que j'ai shippés. Je suis pas fier de chaque ligne de code que j'ai écrit. Voilà, il y a des choses qui sont un peu moches, mais c'était pour essayer, pour voir si ça intéressait les gens. Maintenant les gens l'utilisent, ils me demandent de nouvelles fonctionnalités. Quand je rajoute des fonctionnalités et que je commence à voir que le code commence à être moche, je refactor à ce moment là. Quand je veux tester le code plus fort, je refactor à ce moment là. Par contre je fais pas du code parfait dès la première fois, parce que je veux tester des idées. Et c'est bien ça le problème de Rust, c'est du code oui robuste, mais aussi rigide, et parfois rigide à outrance et pour rien. Voilà. Bah écoutez, j'espère que ça vous a plu, et la semaine prochaine, Positive of Rust, le côté positif de Rust. On a fait tout un article sur tout cet article sur un peu une critique de Rust. Ça va être intéressant de voir ce qu'il en retient et pourquoi il l'utiliserait, les leçons retenues et le positif de Rust. Et bien c'est la semaine prochaine. Bisous bisous.